So what you're looking at is a garden variety circle, which is imposed or superimposed onto a Cartesian grid. And the reason I've done that is because I want you to think of that circle as having its center at the origin, right, 0, 0. And I want you to think of these arrows that you see going from the center out to the edge as being 1 unit long, right? So if that arrow was sitting right on the positive side of the x-axis, then it would mean that the coordinates at this point right here would be the coordinates 1, 0. If I start at that point and regard that as being 0 degrees and what's called standard position, as I start to rotate this line that goes from the center out to the edge, remember it's 1 unit long, as I start to rotate that line in a counterclockwise direction, once I get up to this point up here, then it's now resting at 0, 1. Right, I'm sure you agree with me on that. If I continue to rotate that, and I'm now over here, right? So remember, I started off here, this blue line sitting right on the x-axis, positive side. I started to turn it in a counterclockwise direction. So up here, it's at 0, 1. Over here, now we're at -1, 0. Right? Those are the coordinates of the tip of the tip of this line, this arrow, as it goes in this circle. When it reaches on this side, it's going to be at -1, 0. Then when it reaches at the bottom down here, at this point now, we're going to be at 0, -1. Now, we already looked at radians a couple of days ago. So please remember our work on radians. You mind recapping everything from Friday is what Jeremy is asking. I didn't see your comment before, Jeremy. I'm just seeing it now. Did I do a video of that? I don't remember. But the thing, there was a video which I shared with you on radians. And if I just would quickly say that the radian, it's all right, there was a video, right? A radian is just another way of measuring angles on in space. And we said that 2 pi radians was what we used to call 360 degrees. And we said that pi radians was what we used to call 180 degrees. So on that note, let me go ahead and put some angles in on here that correspond to each of these different positions. So for instance, I remember that this line that I'm pointing to right here started off sitting flat on the x-axis. And we're going to call that 0. Not degrees. Oh, sorry, let me change the color. Not degrees, but radians. Right? So that's in radians. So we haven't moved yet, so we're going to call that radians. Does anybody remember what it would be? No, this is what we used to call 90 degrees up here. So when I start here and I end up here, what we used to call 90 degrees. But now we're going to put it into radians. Does anybody remember what that angle would be in radians? So this is 0 here. What is this angle here? What we used to call 90 would be half of a radian. Well, it's actually half of a pi radian. So it's actually pi over 2 radians. Okay, it's not half a radian, but half of a pi radians. Okay, all right, because my wife had been slow today. Okay, so pi over 2 is the answer to that, Jeremy. And what about when we get to over here, what we used to call 180 degrees? What would we call that in terms of radians now? All right, so I'm over here where the coordinate is at -1, 0. What would we call this? So remember, I've turned all the way through pi over 2. Now I'm over here at what we used to call 180. What would that be in radians again? Help me out here, folks. What's that in radians? Well, if half of a pi radian is here, then what would this be over here then? That's a pi radian, exactly. And if I continue down to here, 0, -1. So remember, I've gone through pi over 2. I've gone through pi. How many radians would it be down here? Right? Down here. What's this? What we used to call 270 degrees would be, no, it's not 2 pi yet, but 3 pi over 2. Good. It's like saying 1.5 pi. So this is a half pi here. This is 1 pi. That's 1.5, or 3/2, same thing as 1.5. And what's another name for 0 radians? If I've gone a full circle, right? So this is a half, this is 1, this is 1.5. What would be another angle that would correspond to 0 radians? It would be 2 pi. There you go. So this could be either 0 degrees or 2 pi. They're in the same position. They're referred to as being what's the word? Oh, please, I forgot what the word is when they're both in the same place. It will come back to me in a minute. But both angles are in the same position. All right. So 0 and 2 pi are both in the same position. Okay. Now here's something you may not have been taught before, but I'm going to spell this out for you right now. You've heard of sine, cosine, and tangent. You certainly have. I know that for sure. Well, maybe you never thought about it this way, but if this thing is 1 unit long, right? If this line that I'm pointing to is 1 unit long, then if I were to put a little triangle here, right? Remember, this line is 1 unit long, then the sine of this angle would be equal to the y-coordinate over 1, which would mean that the sine is really just my y-coordinate. So think of sine as being your y-coordinate. If I were in that same position there, and I wanted to know what the cosine of this angle was, the cosine of this angle would be my x down here over 1, right? Because it's adjacent over hypotenuse. Hypotenuse is 1. So think of cosine as being your x-coordinate. And also tangent, remember, represents opposite over adjacent. Opposite would be my y value, and adjacent would be my x value. So tangent is really the equivalent of your y divided by your x. I want you to think about it that way. Okay, so there's a hand going up. Jeremy, go ahead, please. It's just it's just a short for coordinate. So I'm not writing out the whole word. I'm just saying it's the x coordinate, and I'm saying that tan is my y coordinate over my x coordinate. All right. So now, having said that, let's see if you can answer some questions. Right? If this is 0 degrees, remember I put it in red here. This is 0 degrees. What would the sine of 0 be? The sine of 0. Sine, let me point it to you again. Sine is my y coordinate. I put it in terms of coordinates everywhere. So at 0, I put the coordinates as being 1, 0. At pi over 2, I put it as being 0, 1. At pi, I put minus 1, 0. At 3 pi over 2, I put 0, minus 1. And if it was 2 pi or 0, it would be 1, 0. So having said that, what should be my sine of 0? Let me say it again. Sine is my y-coordinate. So what should the sine of 0, not degrees, but 0 radians be then? What do you think, folks? What's the sine of 0? Sine of 0 is 0 because it's my y-coordinate. My y-coordinate here is 0. So I'm going to go to my second page for a minute here. I'm going to put that in. The sine of 0 is in fact 0. We'll talk about what cosecant and all these other ones are. You should have learned that in grade 11, but we'll come back to that in a minute. Let's get to the cosine now. Cosine is my x-coordinate. So what should the cosine of 0 degrees be, since cosine is my x-coordinate? Harish and Emily and Aksa and anybody else want to chime in on that and think that it's 1? All right, does anybody else think that 1 makes sense? Rounded? It's not rounded at all. It's exactly equal to 1. It's exactly equal to 1 because you're sitting right here on the x-axis. So the angle that you're forming between this line and the x-axis is 0. So it's actually exactly equal to 1. So it means that the cosine of 0 is actually 1. Okay? Let's go back now and ask the same question of tangent. Tangent is my y divided by my x. So take your y-coordinate and divide it by your x-coordinate, and what therefore should be the tangent of 0 degrees? You're still right here, sitting on the positive side of the x-axis, and I see a bunch of people chiming in with 0, and that's absolutely correct. The tangent of 0 is 0. So the sine of 0 is 0, the cosine is 1, and the tangent is 0. Well done. Okay, let's move along now. Let's come up here to pi over 2. and ask all of the same questions again. What would be the, remember, these are the coordinates, 0 and 1. What would be the sine of pi over 2? Right? In radians, think about radians now. The sine of pi over 2. Sine is my y, remember. So absolutely, it would be 1. So pi over 2, the sine would be 1. How about the cosine of pi over 2? What would the cosine of pi over 2 be? What do you think, folks? Cosine of pi over 2. Well done. It would be 0. Cosine is my x. So that would be 0. And finally, what about the tangent of pi over 2? Right? Tangent, remember, is your y divided by your x. Jeremy thinks it's undefined, and Harish is agreeing with you, and Karis is agreeing with you. Really? Undefined? Yes, it is undefined. Let me not make any drama out of this. It's undefined. Or you can put infinity, right? Kind of means the same thing. So that gives us 0. That gives us pi over 2. Let's try pi now. Let's see if we can come up with some answers for pi. So now we're over here. Remember, 0 is here, pi over 2 is here, pi is over here. Okay, let's think about pi now. And I don't mean the one you eat, okay? So you're over here at pi, and you're going to ask the same questions. What's my sine? What's my cosine? What's my tangent? So the sine of pi would be what? What do you say the sine of pi is? Sine of pi. Sine is your y, that's true. So that would mean that the y value is 0. There you go. So the sine of pi would be 0. How about the cosine of pi? What's the cosine of pi? Cosine is my x-coordinate. My x-coordinate is -1. Absolutely. So -1. And how about my tangent of pi? What's the tangent of pi? It would be 0. Well done, folks. It would be 0. Now, I don't have the 3 pi over 2 here, but let's see if we can answer those questions for 3 pi over 2. If I get to 3 pi over 2, which is down here, right? What should be my sine, cosine, and tangent? Let's start off with the sine of 3 pi over 2. What do you think the sine of 3 pi over 2 should be? Help me out. Absolutely, it's -1, right? I don't have that in my table, but I think most of you cannot recognize, or we probably recognize that sine is my y, and my y coordinate at that point is -1. So that represents my sine. How about my cosine? What's my cosine of 3 pi over 2? 0 is correct. And finally, what's my tangent of 3 pi over 2? The tangent, no. Tangent is my y divided by my x. It would be undefined. And finally, if I now got back to 2 pi, anything I had for 0 will be the same thing for 2 pi. So I'm not even going to repeat myself on that because they're in the same position, right? 0 is exactly where 2 pi is, so they're in the same position. So let's move on. Now, all angles are not sitting on an x or a y axis. If that was the case, then this would be easy. We'd be done the class and we could go home. Oh, well, you're already home. But what happens when angles are in between? Well, I want you to consider these two triangles. These two triangles are special triangles. This first triangle is what's called an equilateral triangle, right? Every side is the same. So all the sides are 2 units long. Doesn't matter whether it's centimeters, meters, doesn't matter, yards, feet, whatever. It's 2 units long. And because it's equilateral, I can split up one of those sides into 1 and 1 equally. So both of these two sides that I'm pointing to are both 1 unit long because I've split this side in half. Now, an equilateral triangle means that all angles are the same. Now, what would be the sum of the angles in any triangle? All right. What would be the sum of the angles? This is something you learned back in grade, I don't know, grade probably 6 or 7, 180. But we left behind this degree world and we're now living in a radian world, right? So in a radian world, what would that correspond to? What would be the sum of the angles? It would be pi. There you go. So since all the angles add up to pi radians, what would each one of these angles be? What would this angle here be? What would that angle on the other side be? Remember, you're splitting it up equally in all of them. So look at what Harisha, Joel, we're not talking degrees. You're back in degrees. I don't want to hear about degrees right now. Put on, you gotta move out of that world. All right. It's like translating from English to French or French to English. You gotta think in a different language now. You agree with Harish? And I agree with Harish as well. It's pi over 3 or 1/3 pi. All right, so this will be pi over 3 as well. Now this angle at the top, the one I'm going to point to right now, what I'm going to mark right now, because it's an equilateral triangle, if I took a line and split that in half, it would also split the line at the bottom in half. What would be the size of that angle up there? Right? So that's only half of a full pi over 3. So pi over 3 would be the whole angle, but I just took 1/2 of that. How big is that half? And I don't hear anything about any degrees, right? Y'all gotta leave, y'all gotta become, grade 12. Okay, there you go. Pi over 6. Well done. So that's pi over 6 right there. All right. Okay. Let's go over to the other triangle. We'll talk about the triangle some more in a minute. Let's go over to the second triangle now. This triangle is not an equilateral triangle. And by the way, this side here is √3 because you can just use Pythagoras to figure that out. Remember, Pythagoras' theorem says that if you took that, I don't need to go with Pythagoras with you. You know how to do Pythagoras. But if this side is 1 and this side is 2, this would be the square root of 3. And you can confirm that for yourself on your own time. Let's come to this triangle over here. This is not an equilateral triangle. This triangle is an isosceles triangle. And it's an isosceles right triangle, which means that one of the angles, this angle right here, now, I know you used to call it 90 degrees, but we're not going to call it 90 anymore. What would we call this angle in the corner right here in the radian world, right? This right angle right here is pi over 2. So I'm going to call this pi over 2. These other two angles are what you have left to make up the pi radians that every triangle must have. So pi over 2 is half of a full pi. So we have to split up these two into what's left. There's pi over 2 left. So what would each of these angles be in this triangle? Pi over 4. Okay. So there's a pi over 4 here and a pi over 4 here. So let me remind you about something. SOHCAHTOA. Right? That's not Greek. It's something you learned as a mnemonic back in, I don't know what grade, probably grade 10. I think you probably learned this in grade 10. SOHCAHTOA is just the little mnemonic that you use to figure out whether you're talking about opposite over adjacent, opposite over hypotenuse, all that good stuff. So let's see if we can come up with the sine, cosine, and tangent for pi over 3 and pi over 6 using SOHCAHTOA. Let's start off with the sine of pi over 3. Now, according to SOHCAHTOA, since I'm looking at this angle down here, pi over 3 would be equal to opposite, which is √3, over hypotenuse, which is 2. So it's √3 over 2. The cosine of pi over 3 would be equal to adjacent over hypotenuse, so that's 1 over 2. And the tangent of this angle, well, tangent is opposite over adjacent. The tangent of pi over 3 is equal to √3 over 1, or just simply √3. All right, so those are the angles that I would have for pi over 3. All right, you can confirm that for yourself. Remember, SOHCAHTOA, so sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent, so √3 over 1. How about if I looked at things from up in this angle up here, pi over 6? Let's go to the sine of pi over 6. The sine of pi over 6. So now I'm up here. I'm looking down the triangle at these three sides. What would you say is the sine of pi over 6? Using SOHCAHTOA, it will be 1 over 2. And how about the cosine Sorry. How about the cosine of pi over 6? Let me take you back up to the triangle so you can see it. So you're looking at it up here. What's the cosine of pi over 6? 3 square, you meant the square root of 3 over 2. Good. And how about the tangent of pi over 6? Let's go back and have a look again. What's the tangent of pi over 6? Look at that diagram and you tell me what that is. Jeremiah says 1 over root 3. Okay, what do other people think? Not going to confirm or deny that. All right, look at the diagram, pi over 6. I'm looking for the tangent of that angle. Okay, so we got everybody chiming in and thinking that he's right. Okay, 1 over root 3 sounds good. So these are what we call special angles, right? These are all special angles. Either you're talking about angles that are sitting on the x-axis, sitting on the y-axis, or angles that are, yeah, sorry about that noise in the background, or angles that are from this triangle right here. These are the special angles, and you have exact values for them. Exact values are like root 3 over 2, 1 over 2, root 3 over 1, etc., etc. Let's come over here. Let's talk about the sine, cosine, and tangent for pi over 4. Okay? Try putting this in my calculator knowing that I was in degree mode. Look at you. Yeah. Well, you shouldn't be using your calculator right now, though, Jeremiah. This should all be coming from the special triangles, okay? All right. Let's get to sine of pi over 4, the cosine of pi over 4, using the same SOHCAHTOA principle. All right? So the sine of pi over 4. Look at the diagram. You tell me what's going on. What should the sine of pi over 4 be? Okay, I see one answer there from Jeremiah. What do other people think? What do other people think? 1 over root 2 makes sense to everybody? I agree, and you're absolutely correct. The cosine of pi over 4. You can still see my diagram. What's the cosine of pi over 4? Is cosine the same one? I don't know. I'm asking you. What do you think? It is 1 over root 2. Yes, they're both the same. And how about the tangent of pi over 4? What is that equal to? Look at you all. Look at you, bright students. 1. Okay, opposite over adjacent. It's 1. So let's answer some other questions now. Now that we answered all of these questions, let's answer some other questions. I'm going to go to this little chart over here that I have on the next page. Pi over 6 we have from the previous page. We said that the sine of pi over 6 was 1 over 2. I can go back and show you that again. Sine of pi over 6 right there was 1 over 2. So I put that in. And the cosine we said was root 3 over 2. And the tangent we said of pi over 6 was 1 over root 3. And then we said that for pi over 4, because I'm kind of filling this out, it was 1 over 2, sorry, root 2. The cosine was also 1 over root 2. And the tangent we said was 1. For pi over 3, we said that the sine was root 3 over 2. You can go back and look at your information for that. And we said that the cosine was 1 over 2. I can take it back just so you can see that. Pi over 3. Sine of pi over 3 is right there. Hold on, what am I doing? Root 3 over 2. Did I put that in right? Hold on, let me go back. Sine of pi over 3, root 3 over 2, and this cosine is 1 over 2. Yeah. Oh, sorry, wrong page. Sine of pi over 3, cosine is 1 over root 2, and then for the tangent it was root 3. Now, one of the things that you would have learned is reciprocal ratios, meaning cosecant is actually the reciprocal of sine, secant is a reciprocal of cosine, and cotangent is a reciprocal of tangent. So that means we probably could fill in these things right now because reciprocal just means you flip it upside down. Okay? So look at the first one, the cosecant. If the sine of that is 0, what should the cosecant be, you think? What do you think the cosecant is? Right? Anybody? The cosecant of 0. What do you think remember, cosecant is the inverse of sine. So I don't see any responses yet. Flip it over, folks. Not applicable. Would it just be, okay, let me see, undefined? It is undefined. Right, I'll use an infinity sign for that. What about the secant, which is a reciprocal of cosine? What about the secant of 0? What would that be? It would still be 1. You flip 1 over, it's still 1. The cotangent of 0, what do you think that is? The cotangent of 0. It will be undefined. Well done. Now, let's answer a few more questions from here. If it was pi over 6, the cosecant, which is a reciprocal of sine, would just simply be 2 over 1, or just simply 2. The secant of pi over 6 would be the reverse of this, not the reverse, the reciprocal of that, so it'd be 2 over root 3. This one would be root 3 over 1, or just simply root 3. So whenever we have one of the reciprocal ratios, what we need to do is we need to just flip it over. So this would be root 2. This would be root 2 as well. This is just simply 1. This one is 2 over root 3. This one is 2. This one is 1 over root 3. Now, let me go one more here, pi over 2, because you might find this surprising. I think we all know that this one will be 1, and this one will be undefined. How about this one? What's the reciprocal of undefined? I mean, that might sound a little confusing, but Jeremiah, what do you think it is? Yeah. Mm-hmm. It could be 0. You're correct, right? So you're flipping it over. Instead of saying 0 divided by 1, we're now taking, what did I just say? 0 divided by 1? No, instead of saying 1 divided by 0, we're taking 0 divided by 1. So you're absolutely correct. The answer will be 0. Thanks, Elisa. Thanks, Rylan. Thanks, Rachel. Okay, so we've got that out of the way. But here's the problem, and you're almost ready to do the homework, but you're not quite ready yet. So we need to talk about something else. I'm going to take you now over to a grid that looks like this. We've basically covered what happens when you're sitting right on the x-axis, right on the y-axis. So like you've covered all of those points there, right? So we know that, for instance, the sine and cosine of 0 and tangent of 0, we know what that is. We know what it is for pi over 2. We know what it is for pi. We know what it is for 3 pi over 2. We know what it is for 2 pi. We know all of those things. We also know some special angles that are acute angles. We know that angles like pi over 6 and pi over 4 and pi over 3, we know what those are, because we have that table. But what if we stepped outside of this quadrant? This quadrant is our first quadrant. I'm going to remind you of something you learned in grade 11, and that's called the cast rule. I put that in red. Does anybody remember what this cast rule, this little mnemonic called cast, what that actually is trying to tell you about? But I'm asking something else though. What do you mean by all for quadrant 1? What they're all what? And what does S meaning sine in quadrant 2? What does that mean? What is so sine is quadrant 2. By the way, let me just number these quadrants. We number them going counterclockwise. So that's quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. Okay, so just reminding you about how that this works. Okay, so Noah is saying all positive. That's correct. That's correct. They're saying that all the ratios, meaning sine, cosine, and tangent, are all positive in quadrant 1. So what does the S mean in quadrant 2 then? Yes, Jeremy? Okay. Okay. So in the second quadrant, sine is only one that's positive, and tangent and cosine are negative. In the third quadrant, tan is only one that's positive, and the other two are negative. And in the third quadrant, or sorry, fourth quadrant, cosine is only one positive. Now that we know this thing that I just taught you a few minutes ago about, let me just remind you what I said. I said that the sine is my y coordinate, cosine is my x, and tangent is my y divided by my x. It's supposed to be an x, by the way. Now we have a good reason for that to be the case. I don't know if this is how you were taught this before. The reason they're all positive in this first quadrant is because I'm on the positive side of the x-axis, on the positive side of the y-axis. So since I'm on the positive side for both of them, it means that my sine will be positive and my cosine will also be positive. And when I divide my y by my x, if I divide these y values by my x values, I'm going to get a positive number. So that's why they're all positive. But on this side over here, in the second quadrant, let's see if what's what Jeremiah saying, tangent is positive. Okay, good. But in this second quadrant, guess what? I'm on the negative side of the x-axis, but I'm on the positive side of the y-axis. So if I'm on the positive side of the y-axis, that means that my sine, which is my y-coordinate, would be positive. But cosine, though, would be negative because I'm on the negative side of the x-axis. And my tangent is going to be negative because I'm dividing a positive by a negative. Now, when I come down here into this quadrant, I'm on the negative side of both x and y, which would mean both sine and cosine are negative, but because they're both negative, when you take the ratio of those two things, that means that tan is going to be positive. And over here, I'm on the positive side of the x-axis, and that's why cosine is positive. I'm on the negative side of the y-axis, that's why sine is negative. And then when you divide a negative by a positive, you end up with a negative. And that's why the CAS rule makes sense. No. Why am I going through all of that? I'm going through all of that because some angles are not in the first quadrant and are not sitting on the x or y axis. We have to consider some of those angles. So let me, first of all, delete or erase some of these things here. Hope I'm not going to lose my stylus thing because sometimes that's what happens with this. Let's see if I can still write with my stylus now. Okay, good, perfect. All right. So actually, let me erase this though first. I don't need that there. Okay, let me go back to my stylus now. Let's take an angle now that's in the second quadrant. I'm just going to draw a line in that second quadrant. Put that line in maybe blue. So there's my line right there. Okay? Excuse me. And let's say that when I measure from here around to here, that angle, remember, I'm in the second quadrant. I'm going to give you an angle which is in the second quadrant. Let's say that that angle was 2 pi over 3. Now, think about 2 pi over 3 as being bigger than a half a pi, right? Half a pi is here. 2/3 is more than a half, but it's less than a whole pi. A whole pi would be right here, but 2/3 is somewhere between a half a pi and a full pi. That's where 2/3 is. All right, so that's why I'm over here. And I'm measuring the angle starting from what's called standard position. So from the positive side of the x-axis. And this whole angle here is 2/3 of a pi. So now I'm asking, oh, that's not in my table. If I went back and looked at my table here, right, or my table here, I don't have 2/3 pi in the table. What am I supposed to do with that angle? I'll tell you what you were supposed to do with that angle. Ask yourself, how far am I from the closest x-axis? What is that distance right there that would take me from where I am right now down to my closest x-axis, right? What is that distance in radians, not in degrees, but in radians? How far do I need to go to get to that x-axis, which I'm not quite yet at? What's that distance? What's that gap? Can anybody help me out with that, right? It would pi over 3, absolutely, 1/3 pi. So what I'm going to do is I'm going to use that 1/3 pi as what's called a related acute angle, RAA. The related acute angle is pi over 3. Right? And I'll write this up here, related acute angle. Related acute angle, meaning an angle that I can use to represent the 2 pi over 3, which is an acute angle, related acute angle. So what I'm going to do is, for that 2/3 pi, I'm going to ask for the cosine, tangent, sine, cosine, and tangent of 2 pi over 3. So I'm going to come over here and write that in. The sine of 2 pi over 3 is going to be the same as, I'm going to erase this here, is going to be the same as the related acute angle as the sine of just simply pi over 3. But the other question I need to ask is, could I explain why it's 1/3 pi? Really is asking? Absolutely, really. Absolutely. So really, if I'm 2/3 pi, if I'm at 2/3 right here, right, to go from here to here is 2/3. Remember, I've gone past half and I'm 2/3 into this rotation. So how much do I need to add on to that to get me to pi? Because that's really what I'm asking. It's like taking pi and subtracting 1/3 from it to get me back to this point right here. Do you see why that is? Right? Because I need another 1/3 pi to get me all the way to the closest x-axis. Do you see what I'm saying that, Rudy? And thank you for the question, by the way. Does that make sense? Need another 1/3 to get, okay, good. So that's why, okay. And I'm saying that the related acute angle is pi over 3. So I'm going to say that the sine of 2/3 pi is the same as the sine of pi over 3. And because I'm in the second quadrant, I'm not going to change the sign as in the positive or negative. It's going to be the same thing. So we said the sine of pi over 3, remember, if you remember from our table, was equal to √3/2. And you can check your table for that. And that's why that answer is what it is. Why they're equal to each other though? Okay, because the related acute, we don't have 2 pi over 3 from our special angle. Isn't that true, Jeremiah? It's not in the special angles, right? But we can find an angle that is related to it. That's what we call it, related acute angle. And the related angle is pi over 3. That's the angle that takes us to the x-axis, the closest x-axis. So we're going to call it the related acute angle. And I'm saying that the 2 pi over 3 is going to be the same as the sine of 2 pi over 3 with the same sign meaning positive or negative because I'm in the second quadrant. So sine is still going to be positive, and that's why it's going to still be √3/2. Okay? Let me go to cosine now. Cosine of 2 pi over 3. Well, we're going to use the same related acute angle. It's going to be equal to the cosine of pi over 3, but I'm in the second quadrant. So because I'm in the second quadrant, I have to make it negative, right? Because we said, according to the CAS rule, over here, only sine is positive, right? So it's going to be equal to whatever the cosine of pi over 3 is, it's going to be the negative of that, which is -1/2. Okay? -1/2. Let me go to tangent now. The tangent of 2 pi over 3 is going to be equal to the same as the tangent of pi over 3, but it also is going to be negative because I'm in the second quadrant. The second quadrant, only sine is positive. That's why only the first one here was positive. The rest of them are going to be negative. So whatever the tan of pi over 3 is, which I believe is √3, and I can double check that because I don't memorize these things, right? Let's go back and look at the tan of pi over 3. Yes, it's √3/1 or just simply √3. So it means it's going to be equal to √3, but it's negative. So it has to go to the nearest x-axis only. Correct. 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 Okay. So let me take this diagram now and replicate it into another, because we're going to do this again for another quadrant. Okay. So give me a second here to take this thing. Actually, no, that's not going to do it. How do I do this now? All right, you know what? I'm going to have to erase all of this because I want to use this for another angle. Do I have this on another page? Let's see if I do have it on another page. All right, okay. Let's do one. Actually, let me copy this first. Let me take out this line right here. Can I take this out? Yeah, let me take that out. And then let me copy this so I can use this again and again for different angles. Oh, hold on. Okay, so copy and paste. And we do another one. Okay. All right. Let's move the whole thing over. Move the whole thing over. Okay, we go back now. So I don't have to use this one again. I'm going to use this one here, this brand new one. So here's what we're going to ask now. So this has to go to nearest exact. Okay, right. I'm going to put an angle now which is in the third quadrant, right? And this angle is going to be, let's see, I'm going to use let me see, I want to think of a good one to use. Let me think of 7 pi over 6. So I'm going to use 7 pi over 6. And how do I know that's in the third quadrant? Let's think about this. This is half. This is a whole. So 1. This is 1.5. 7 over 6 is somewhere between 1 and 1.5. You can confirm that for yourself. So I'm going to say it is down here. Right? Again, I'm measuring from here, and I'm all the way over here. So the question is, how far am I from the closest x-axis, not the closest y-axis? What's my RAA in this case? What's my related acute angle? Give me some help with that, please. Harish says pi over 6, and Noah agrees, and I completely agree with that as well. So there's my related acute angle, pi over 6. So I'm going to answer all the same questions again for sine, cosine, and tangent, but now I'm looking at a third quadrant angle. So here we go. The sine of 7 pi over 6 is the same as the sine of pi over 6, but it is going to be negative because I'm in the third quadrant. Now, the pi over 6, if I remember correctly, was a half. So it's just going to be minus a half. The cosine of 7 pi over 6 is going to be equal to the cosine of pi over 6, but negative. And I believe that was root 3 over 2, but negative. The tangent of 7 pi over 6 is going to be the same thing as the tangent of pi over 6, but it is not going to change sign because it is positive being in the third quadrant. So whatever tan of pi over 6 was, which I believe is 1 over root 3, is still going to be 1 over root 3. Let me give you a fourth quadrant angle now. So I'm going to skip over this one. Hopefully that made sense. Let's say that my angle now was, let me think of an angle in this quadrant now. I'm going to say 7 pi over 4. And I'm going to say that 7 pi over 4 is right here. How do I know that? Well, think of 7 pi over 4, right? This is half a pi. This is 1 pi. This is 1.5 pi. This is 2 pi. This is not as much as 2 yet, 2 pi, because 2 pi will take me all the way up to here. And 7 over 4 is not as big as 2, right? But those are all points on the unit circle. No, okay, what is Noah saying now? Those are all points on the, yes, these are all points on the unit circle, absolutely. Yes, Noah. Not sure what the question is, though. All right. Okay, so my question again is always, what is this angle that takes me up to the closest x-axis? That's my RAA. Now, a student noticed this some time ago, and I should just repeat it. The clue to this is just look at the denominator, because that's always the RAA, right? If you have it, if it's pi, if it was anything over 6, then it means the RAA is pi over 6. So that was a little thing that a student noticed. And I actually think that's a little shortcut way to get it. So the RAA is here is pi over 4. Okay? So now we're going to ask for sine, cosine, and tangent of 7 pi over 4. Sine of 7 pi over 4. Cosine of 7 pi over 4. And tangent of 7 pi over 4. Bear in mind, I'm in the fourth quadrant. Okay? Yeah, that's a shortcut. That's a nice shortcut. Learn that from a student. I was not thinking about that until that student pointed that out to me. Anyway, excuse me. So remember, sine of 7 pi over 4 is the same as the sine of pi over 4, but negative. Pi over 4, if you remember, was 1 over root 2. So it's 1 over root 2, but it is negative. The cosine will be the same as the cosine of pi over 4, which does not change because I'm in the fourth quadrant. So it's just 1 over root 2. The tangent of 7 pi over 4 is the same as the tangent of pi over 4, but negative. So that would be equal to negative 1. Okay, will we have this table to refer to on the Simonson test? You will have, you're supposed to, you see that those little triangles, you can certainly use those triangles, set up the triangles. Because to be honest with you, I don't memorize these things. If you woke up in the middle of the night and asked me for the sine of pi over 3, I'd have to draw the triangles to do it. I don't memorize it. I really don't. All right. So once I have my triangles, I'm good to go. All right. So don't stop me in the middle of the road and ask me that question, because I'm gonna have to offer some paper and pencil to figure it out. I don't memorize it. Right. But I know how to get it. I know how to figure it out. Okay. All right. So let me throw a few angles at you now. The triangles and that big chart. Yeah, there you go. There you go. Right. Then also remember, by the way, Jeremy, that sometimes you don't need the triangles. What you just need is to know where you are if you're on an x axis. If you're on an x or y axis, then it's just going to be either 1 or 0 as your coordinates, and use those coordinates to figure out whether it's sine, cosine, or tangent. Okay, hopefully that makes sense. All right, let me throw a few angles at you now. Then we're going to talk about what happens when you go in a negative direction as well, because that's also going to be on your homework. So let's go to this thing here. Let's go. Actually, let me just copy one more of these. Copy a few more of these. I think we might need a few more just to round this out. So let me copy and paste that in and do one more. Actually, need another page. Okay. All right. Let me throw a few angles at you now. Hall pass, Elizabeth says. Okay, you have to go appointment now. Okay. All right, so Kristen, please make sure you watch the video later on, okay? All right. So let's talk about negative now. No, actually, before we get to negative, let me throw a few angles at you, because so far I've kind of told you where the angles were. I said it's in quadrant 1, 2, 3, or 4. What if you had to figure it out? Right? Let's see how well you can figure this out for yourself. And then we can figure out what the rest of it is. What if I gave you the sine, cosine, and tangent of, let's see, the sine of 4 pi over 3? Where is that? What quadrant am I in for 4 pi? So I'm not giving you the quadrant anymore. Which quadrant is that? 4 pi over 3. 1, 2, 3, or 4? Okay, so I got two people saying they think it's in quadrant 3. Jeremiah, Karis, and Emily, and Rachel, and Riddy, and you're absolutely right. It is in quadrant 3. So I'm over here. Okay, so what do you think and you can use your little table for that now, or the triangles for that now. So what would you say is the sine of 4 pi over 3 if that's the case? Because we know the RAA is pi over 3. So what should that be equal to then? Pi over 3, yes, Karis. Pi over 3 is the RAA. So what should the sine of 4 pi over 3 is then, since you know that? Should be negative, and negative what? Go find what the sine of pi over 3 is. Yeah, go back, or Elizabeth is back. Good, Elizabeth. Go find that, go back and look at what we said the sine of pi over 3 was to help you out with that. Right? What is that equal to? Nobody remember? All right, I'll tell you. It's root 3 over 2. I know I said it memorized, but I just did it a while ago, so it kind of stuck in my head. So it's minus root 3 over 2. Right? Good. Now, the other thing is, remember that if I was asking for the cosecant of 4 pi over 3, then what I would do is I would take that answer and turn it upside down, minus 2 over root 3. You're going to get questions like that as well. So the cosecant, remember, is the reciprocal of sine. So let's take that answer I got for sine and just turn it upside down. Just flip it upside down. So the cosecant of 4 pi over 3 is minus 2 over root 3. Just saying, just saying. Okay, let me throw another one at you, and then we're going to talk about what happens when you get a negative angle. What if the angle that I was going to be asking you for was, let's say it was 3 pi over 4. What quadrant am I in now for 3 pi over 4? Anybody, help me out. 3 pi over 4 is quadrant 1, 2, 3, or 4. Well, I don't think I can fool you guys at all. It's over here, right? So what's the RAA? Use that little trick that that student taught me. What's the RAA? It's pi over 4. There you go. So since I'm in the second quadrant, the sine of 3 pi over 4 is equal to 1 over root 2. Check that for yourself. Right? 1 over 4 pi. Yes, okay. And the, what is it now? Cosine of 3 pi over 4 should be equal to 1 over root 2 as well, but negative. The tangent of 3 pi over 4 is equal to minus 1. Double check those and make sure those all make sense to you. Now, we're at 2:30 already. We're coming up to the end, and I still haven't done negative yet. So let's talk about what negative means. The rotation doesn't have to be going in a counterclockwise is what we've done all along. If you go in a clockwise rotation, then it changes things up. So for instance, this angle right here, right, which is pi over 3 away from the x-axis, right? So, but what if I was going this way instead? Now this angle would now become, so this is pi, let's say this is pi over 3 away. This angle that I just put in right here, measured in a, if I was measuring this in a regular counterclockwise fashion, then that'd be one thing. But if I'm measuring it in this direction, that would be the same thing as minus pi over 3, right? That's what that angle is that I just put on the screen. And you still ask for the RAA based on what the denominator is. So the RAA in this case would be still pi over 3. And because you're in the fourth quadrant, I'm pretty confident that you would all know what the sine, cosine, and tangent of that is, but I'm going to quickly do that with you. So the sine of minus pi over 3 will be the same thing as minus the sine of pi over 3, which is equal to minus root 3 over 2. Okay, why is it minus? Because I'm in the fourth quadrant. The cosine of minus pi over 3 is the same thing as the cosine of pi over 3, which would be equal to 1 over 2, which will be positive because I'm in the fourth quadrant. The tangent of minus pi over 3 is equal to the minus tangent of pi over 3, which I believe is minus root 3. Okay? Let me throw another angle at you. Let's see how good you are. Oh, I don't know, I'm extended page. I need to go to a different page. Oh, I need to copy this thing again. Let's see if you can figure out where this angle is, a negative angle, a negative angle. So let's say I now said minus 7 pi over 6. That's a bit of a challenge to you. Where is minus 7 pi over 6? Not positive 7 pi over 6, but negative 7 pi over 6. What quadrant am I in now for negative 7 pi over 6? Remember, I'm going in a negative direction this time, right? I'm starting here, and I'm going like this. So I'm going past, this is minus pi. Sorry, minus pi over 2. I'm sorry, that's wrong. That's minus pi over 2 here. This would be minus pi here. And I'm not going to get to minus 3 pi over 2. I'm not going to quite get there. I'm somewhere in between those two. So yes, it's right there. The RAA is still pi over 6. That doesn't change that. But you're right. I'm in quadrant 2 now. Right? I've gone past the 6 pi over 6, which is minus 1. And I've gone into 7 pi over 6. So whatever I have for sine, cosine, and tangent is based on a second quadrant answer. Second quadrant angle, rather. All right, let me throw 2 more at you. And if you get these other 2, then I'm going to be satisfied that you're ready for your homework. Oh, by the way, let me answer another question. What would be the cotangent of minus, let's all answer this question, of minus 7 pi over 6? Well, that's equal to the cotangent of pi over 6, but negative, right? Remember, it's negative because I'm in the second quadrant. You all told me it was in the second quadrant. And I need to know what the cotangent of this is. So think of what the tangent of pi over 6 is. I believe it's 1 over root 3. So that means I'm going to flip that over, make it root 3 instead, and therefore negative because it's the cotangent of that. So remember, ask yourself what is the tangent of pi over 6 and take that answer and flip it over and then put the negative on it. So there's a couple of things. Cotangent is for tangent. Yes, Jeremiah. Cotangent is the reciprocal of tangent. Okay? And so cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is reciprocal of tangent. All right, let me throw, before we finish the class, let me throw two more at you. Let's see if you seem to be good, but let's just see how good you are. Let me paste in two more, just two more. One more page. Okay, so here come two more negative angles. I'm going to throw them at you now, see how well you do with this. So how about minus 3 pi over 4? Where is that? What quadrant is that in? Jeremiah thinks it's 3 for some reason. Okay, all right. I don't know. Is that what everybody else thinks? You think it's also 3? What do y'all think, folks? Jeremiah, he says 3. Wait, Noah's on your side? Elizabeth is on your side? Wait, is everybody going to say it's 3? Y'all really think it's 3? Is that where you're going with this? Okay, I'm not moving. You're not budging from that at all because y'all know you're right. Okay, y'all know that you know what you're talking about. So yes, that is in fact a third quadrant angle. So let me throw one more. And if you get this, then I'm just gonna turn you loose. All right. So let's see now. How about so by the way, this one is right here, and it would be pi, and the RAA is still pi over 4. Sorry, pi over 4. All right, last one, and then you can get started on your homework because the homework should now be available. How about if I give you, here's a good one. Minus 11 pi over 6. Let's see you get that one. Okay, where's that angle? 11 minus 11 pi over 6. What? Are you serious? You're all going for 1. All right, well, I give up. I can't talk to you guys. There's no way that I can put anything past you. I'll get up too early in the morning for me to get anything past you. You're absolutely correct. So the RAA is going to be pi over 6, but you're going to treat it as if it's in the first quadrant. And then you're just going to look at your table, look at your little triangle, and figure it out from there.